Welcome to Ascending Kcse, where we have an interactive platform. Our focus is to elevate your grades, and in turn, when your grades are good, then your future will be also good. Welcome to color trial examination, that is of 2025 physics paper 2. This one was of July of 2025. So welcome on board. So we are going straight to question 1, section A. Then this one reads, a shadow refers to a dark area or shape produced by a body coming between rays of light and a surface. State one factor that influenced the nature of the shadow formed. So from a good analysis, I'll give 2 points. And the first one, we have the distance. The distance between the source of light and the object. Then we have another one, the size of the object. The size of the object. So now we have question 2. The graph in the figure below was obtained during a magnetization experiment using a single stroking method. Then you are asked, it was observed that increase in number of strokes increases the magnetic strength to a certain point where magnetic strength remained constant. The question is very key. Using the domain theory, give a reason why the magnetic strength remained constant after some time. Remember, the moment you are magnetizing a material, it comes to a point where the dipoles, all of them, align in the same direction, all of them. And this is the point where we say the material is magnetically saturated. And this is the point where you cannot add any more magnetic strength, even if you continue magnetizing. Therefore, we can have summarize one sentence. The strength of the magnet remains constant when all the dipoles in the domains align in the same direction. Here we can say that the magnets become saturated. We have question 3. Besides temperature and humidity, name one other factor that affects the speed of sound in air. the remaining point is wind direction. And how does this one affect the moment a sound is traveling the same direction as the wind? Then its speed will automatically increase. Our question 4 reads, a watch noticed a small chain hanging from the chassis of a petrol tanker as shown in the figure 2 below. He kept wondering what its function could be. So we are having the tanker here. A student at Kala High School as a student at Kala High explain the function of the chain. So, what will be the function of this chain? This is an application question from Electrostatics 1. The discharge of electrons or charges. So, why is it safe to carry these petroleum products in metallic cans rather than in plastic cans? It is because the moment you are carrying them, you are always in motion. The liquid is also in motion. It creates friction with the walls, creating charges. And these charges can make the liquid to explode. Therefore, the moment this tanker is moving, the charges that will be created for safe discharge, there is a chain that acts as earthing. Therefore, I can say the chain acts as earthing. Acts as earthing, discharging, excess charges created by the movement of created by the petrol inside the tank. So that will be the explanation for the same. The figure below shows a defective eye whose defect has been corrected by a lens shown. Then you are told, name the defect that has been corrected. If you look at the lens that has been used here, it is the converging lens. So converging lens helps to keep a more converged rays. And this one is telling us that this eye was forming images behind the retina. And this defect is called the long-sightedness. Long-sighted. What does it mean? This person can only see distant objects and not the close ones. It is caused by too long focal length of the eye and too short eyeball. And you also need to know that the image will be formed at the back. can move on to the next question. We are having this figure here. Having this figure here, which is a array diagram. Now we are having array diagram that needs to be drawn over here. Therefore, in this case, you are told an object is placed in front of a concave mirror. You can see it is placed between F and C. Then use appropriate rays to locate the position of the image, and it has been awarded to marks. Remember, for you to draw the rays, for you to form the image, then you need to know the rules governing array diagrams. So we're going to use the first array, which is array that is close and parallel to the principal axis, and it must be touching the tip of the object. So that is the first ray. This ray will be reflected back through F. It will be reflected back through F, like this. High levels of accuracy is needed. High level of accuracy is needed. Minus bent. So I'm going to redraw it. Mine is that. Then now you must indicate the ray direction. We have the second ray, which will be a ray that is passing through the C, which is the center of curvature, and it must also touch the tip of the object. So this is how mine will be like. So these two rays will join at this junction. Mine may not be accurately drawn, but I'm trying my best. Like that. Then allow me extend the principal axis like this, so that it gives us a place where we can show that our image was formed. So an inverted image is formed at that point. And then we're going to indicate the direction. So that is where our image I will be formed. So the second ray, which is the ray passing through the center of curvature, can move forward and backward through the principle of reversibility of light. So the direction, then the image. So the rays have their hallmarks, then the image itself, indicating the correct image, will be awarded a mark. We're having question 7 here. And which reads, give to, in the 3-pin plug shown in the figure below, the earth pin, this one, is longer than the live and the neutral pins. Number one, in most sockets, they have what we call shutters. They are somehow secured, where we have the live and the neutral parts being covered. Therefore, the only way to open them is through the earth pin. So the moment the earth pin enters first, it is going to trigger the opening of these shutters. So it presses, it is longer to press or open to press or open the shutter. Then number two, it is also a safe measure. A safe measure to ensure the device is first earthed. So if it is first earthed, then this is like it is being protected. We're having question 8. The figure below shows 3 capacitors connected to a power supply of 5 volts. Then you are asked, determine the total charge stored in the capacitors. So the first step in this case to do is to look at the capacitance, the total capacitance in this. So we are having 2 stages. We have the parallel stage, and this parallel stage, its combined capacitance will be in series with the 6 microfarad. Therefore, capacitance in parallel this one will be given by direct addition, that is 4 microfarad plus the 5. We arrive at 9 microfarads. Then now, the total capacitance will be given by now this one has become 9 microfarads and it is in series with the 6. So what will happen in this case, where we say 1 over Ct is equals to 1 over C1 plus 1 over C2, or we can say Ct is same as C1 times C2 over C1 plus C2. So we'll say it is 9 times 6 over 9 plus 6. This is 54 divided by 15. And this will give you 3.6 microfarads. But the question is asking about the total charge. Charge is given by capacitance times the potential difference, where our capacitance is 3.6 microfarad. But in this case now, we are going to write it in SI units. So this one is changed to farads. And this one will be done by multiplying by 10 raised to power negative 6. So it will be 3.6 times 10 raised to power negative 6 multiplied by 5. And this is going to lead me from the computation 1.8 times 10 raised to power negative 5 coulombs. So we are done with question 8. Then the power produced at generating station is stepped to high voltages for transmissions. Yes, question 9 reads, the power produced at generating station is stepped to high voltages for transmission. Explain the reason behind this. So the main agenda for this one, the moment you raise the voltage, then automatically you're going to lower the current. And this one, from the formula of P is equals to I squared R, then you are going to lower power loss because the current will be lowered. So you can say at high voltage, power loss is minimized. Power loss is minimized. That is P is equals to I squared R by lowering the current. By lowering the current. Can move on to the next question. We are having a test in the electromagnetic spectrum, where we are having these radiations. Yes. Then we are asked, we are having the radio waves, infrared radiation, we have the visible lights, we have radiation A, and we have the X-rays, and then we have the gamma rays. So in this case, you are asked, what will be A? What will be A? A is going to be the UV light or the UV radiation. So automatically it is going to be the UV radiation. And then you just need to write the UV radiation, ultraviolet. States a reason why the caps of the cells of a lead acid accumulator are opened when charging the battery. Remember, these leads, they do produce a gas which is hydrogen gas, and then for it to come out, then it needs them to be opened, or you just need to have them having some small holes. So if they just do not have small holes, then you need to have them opened. So to allow the hydrogen gas produced to escape, or you can say to be discharged. We have our question 12 now. This one, we have the P-N junction, and is having the forward and the reverse bias. So if the P is connected to the positive terminal and N is connected to the negative terminal, then we say this one is forward biased, whereas this one, because it is the opposite, then we say it is reverse biased. It is reverse biased. So now we are having now the question here. It is observed that in A, current in A is greater than the one in B. So look at them very carefully. So you can say in A, we have what we call the depletion region. From the way it is organized, then it is narrowed. And this one makes more electrons to flow or cross over. Whereas in B, because it is reverse biased, the depletion region, it is widened. The moment it is wide or it is large or increased in size, it reduces the number of electrons that will be flowing. So I can say in A, which is forward biased, the depletion region is narrowed, making more electrons. To flow or cross over. So in B, which is the reverse biased, the depletion region next depletion region widens, preventing or reducing the number of electrons flowing. So that is how this one can be explained. Then now we have question 13 and 14, so that we can be done with section A. The figure 8 below shows a simple form of cathode ray tube which produces a sharp shadow of Maltese cross. Name the property of the cathode rays that was being investigated above. So if you look at it, the Maltese cross will be acting as a barrier, then it has formed a shadow. This means that these cathode rays were traveling in a straight line. These Maltese, the cathode rays were traveling in a straight line. So you can say the cathode rays, or can say they travel in a straight line. In a television set, magnetic fields are preferred for use as deflection system instead of electric fields. Then you explain. So this one, the difference is in televisions, because we have advanced to the flat screens where we need to have very short distance from these cathode ray producing area, then how will it be safe so that we can keep on minimizing the distance? We need more deflection, and this more deflection will be done by use of magnetic fields. So you can say magnetic fields provide a wider deflection to light, a wider screen. So it is giving very perfect wide deflection. We have our last question in section A. An electric element rated 2 kilowatts is used to supply it for 24 minutes when connected to 240 V source. So you are asked, what is the meaning of the rating of 2 kilowatts and 240 the element? So it has a power rate, it has a power rating of 2 kilowatts, or in short, it can do a rating of work within a second, which is of 2 kilowatts. Then the 240 we can say now it is operating at, because there was a comma here, operating at 240 volts. 240 volts main supply. So it is connected to a potential difference or a main supply at 240 volts. Determine the electrical energy consumed in kilowatts hour. So this one just need to convert the time that it is being used into hours, then you multiply by its power rating. So number of hours in this case will be 24 minutes. You divide by 60, and this one will be giving us 0.4 hours. Then the second case, now we look at the energy consumed. I will say energy consumed will be the power rating times the number of hours, which will be 2 kilowatts, which is 2000 watts. Sorry, I'm supposed to talk of kilowatts. 2 kilowatts times 0.4 hours. So in this case, we are going to arrive at 0.8 kilowatts hour. So, in case of